You may have come across one of these strange little objects called resistors that are connected into a circuit. These resistors are denoted as zigzag lines when drawn in circuit diagrams. Resistors can contain a resistance of a specific value that can be manipulated to provide many different kinds of characteristics in electrical engineering. However, what is resistance? Resistance is measured in ohms and is denoted by the Greek omega letter. If we can think of a conga line, we can think that electrons that are loosely bounded to atoms flow into one direction. This flow can be considered as the conduction of electrons, and this conduction of electrons is determined by the potential difference between two ends. However, in reality, that flow of electrons isn't as perfect as it seems. Resistance occurs when heat energy vibrates atoms, producing hindrance to the flow of electrons. By hindering these electrons, this in turn converts some of the kinetic energy of the electrons into heat or sound. The equation here denotes the resistance present in a wire, where it can be seen that the temperature coefficient and the temperature of a wire does affect the resistance. There is also a linear proportional relationship between the resistance and length. This means that by increasing the length of a resistor, this also increases the resistance. The same applies by decreasing the cross-sectional area of the wire, which also increases the resistance. One of the best ways to visualize resistance is through this comic where we can see that the flow of current is being restricted by the ohm guy. As mentioned earlier, by reducing the cross-sectional area of a wire, this in turn increases the resistance of the wire. This image also happens to describe Ohm's law where V equals IR, where voltage is equal to current times resistance. By lowering a resistance, we can get a high voltage, and the same applies to the current. In a circuit, the total resistance is determined in different ways depending on the arrangement in the circuit. In a series configuration, the total resistance is the sum of all resistance present in the circuit, while in a parallel circuit, the equation to determine the total resistance is denoted below the parallel circuit, where the total resistance of the circuit is always less than the value of the smallest resistor. In more complex circuits, finding the total resistance can be a little tricky, where this involves in more steps to find which resistors are in series or parallel. However, by splitting up different areas of the circuits into series and parallel sections, this will make it much more easier to determine the total resistance. I hope you enjoyed the video and know more about resistance. Thanks for watching.